Okay, so we are doing sections 3.1 and 3.2 today, so hopefully we can get through them. It is 7 pages of notes, so it's kind of a lot for 2 sections. That's why I'm only doing 2 today. So section 3.1 is on measures of central tendency. So, oh my gosh, this is like my 8th time yawning. I'm so sorry, everyone. Okay, so measures of central tendency talk about where like maybe the center of a data set is. So that's really what we're talking about today. And there's a few methods for this, and we're just going to talk about a few different properties maybe of a data set that you can calculate that will kind of tell you maybe where the center of the data set lies. So measures of central tendency, where does the center tend to? So first of all, though, we're going to start out with a little definition here. It is talking about the difference between a statistic and a parameter. So if you remember when, I think it was like day 2 of class, but we talked about the fact that when we're doing a study, a population is usually too big. So if you're, wanting to see how men respond to something, you cannot survey every man or do an experiment on every man, obviously. So you need to use a sample. So statistics versus parameters really get into the difference of a population versus a sample. But sometimes when populations are small, we don't need to use a sample. So maybe your population is just like your class or something. So like this class, like 8 people. Obviously, you don't need to take a sample because this population is so small that you can just survey all 8 of us or, do an experiment with all 8 of us. So sometimes when a population is small, you don't need a sample. So just keep that in mind here. But first of all, we will define what a statistic is. So it is a characteristic or measure obtained using data values from a sample. So when you've done a study or an experiment and you've found some results and you used a sample, this would be called a statistic. And I know a lot of the times everything gets called a statistic, but if you've used the whole population, it's actually called a parameter instead. So a parameter is a characteristic or measure obtained using the data values from a specific population. So cross out the house buying scenario here. I'm just going to talk about something else. So I'm going to just talk about an example of a statistic versus a parameter. So the example I'm going to talk about is maybe we're talking about a group of sales representatives for a company. So that's our background here. So an example would be the average sales. So if you add the average sales from a sample of sales representatives. This would be a statistic. So this is a statistic. But if you had the average sales from the whole population of representatives, this is a parameter. Okay, so that's really the difference. So maybe we're talking about a small company, and so to get the average sales from all of the representatives there is not too difficult. So it would make sense just to get the whole population. So maybe it's just a single company, or maybe you have a chain. So you have a lot of sales representatives like all over the country. That would make more sense just to do a sample, and that would be known as a statistic. So that's just the difference between the two. And the reason for even defining these will become clear in just a second. But first, before we get into mean and stuff like that, we are going to talk about the general rounding rule. So the general rounding rule just says that when computations are done in the calculation, rounding should not be done until the final answer. So what that means is, let's say you're finding, so we're going to talk about standard deviation today, but let's say you're finding standard deviation. That is something that has multiple computations along the way. So it's like a sequence of computations to get to your final answer. You shouldn't round until you get to the final answer. So if you're at like step 1 and you already go ahead and round your answer at step 1 or whatever you're finding in the first step, and you continue to round answers as you go, this can really affect your final answer. So it's recommended that you try not to round until the very end. You will see in the textbook sometimes that they do round, but they are very clear in stating that they only round because they don't want to write all the decimal places. But when they do the calculations, they make sure that it's fine. So just a general rule, try not to round until the very last part, because sometimes when you do it along the way, you'll end up getting something that's not really correct. So just a rule of thumb here. So rounding at each step can cause your final answer to be off. Okay, so now we're really going to get into one of the measures of central tendency, and that's the mean. So you've probably all heard of the mean. It is the sum of the values divided by the total number of values, or this can be referred to as an average. So maybe you've heard it stated like that. The mean should be rounded to one more decimal place than occurs in the raw data. So just an example, let's say all of your data points that you're dealing with are just like integers. So they're just like 1, 3, 5, 9, -1, something like that. Like they're just whole numbers here. When you calculate the mean, you should have one decimal place. So if your data all have one decimal place, your mean should have two decimal places. So it should always be one more than the raw data that you're using. Okay, and that's just the definition of the mean. So we're going to talk about two, like, I guess, different kinds of means is what I would say. So right here, you have the word statistic pointed at this X with a bar on top, and then you have the word parameter pointed at this funny looking U. Maybe you know that that's called mu. So let's just talk about the difference here. So this first one, this is called X bar. So this is said literally as X bar. So I'm just going to write that down because it's always nice to know how to read off math, because when you're talking to other people or maybe your classmates, it's nice to know, oh, this is referred to as X bar. So you can verbally communicate about math. So X bar is going to be the mean using sample data. So this is why in the first place we defined a statistic versus a parameter. And that's because a statistic is using a sample. So we actually have two different types of means here. So this is referred to as like the sample mean, and this one's going to be referred to as like the population mean. Just for reference here. So this first one uses sample data. Okay. The formulas for the means are exactly the same, but they just want to clarify that there's a difference. So if you're finding the mean with just a sample, it's referred to as X bar. And if you're finding the mean and you use the whole population, it's referred to as mu. So they're just clarifying and making a distinction between the two, even though the way you find the mean does not change. The way you find the mean is always adding up the sum of the values divided by the total number of values, but they just want to make the distinction between a statistic and a parameter next to the mean. So X bar is just going to be equal to adding up all of the values. And I'm going to refer to all of my values as X1, X2, X3. So like this is equal to X1 plus X2 plus X3, where these are just data points. So I'm just adding up all the data points. And let's say I happen to have n of them. So plus Xn. So I add them all up, and then I would divide by the number of them, which is n. Another way you can write this that your textbook will do is the summation symbol. So that just means you're summing up all of the data points and then dividing by them. So you'll see both things written in the textbook, so I wanted to talk about both of them. So this is just the summation symbol, and this is just saying that you add up all the data points, which is the same as just writing out, summing up all of the data. And then it's important to note that this is where n is the total number of values in the sample. So it's the same thing as the definition, you just add up all of the values and divide by the total number of values. And then let's talk about this one below, which is a parameter, and I just want to tell you that this is pronounced as mu, just so you know. Kind of a fun looking U, but it's pronounced as mu. And this is just when you're using all values in the population. Let me just make that distinction. So uses all values in the population. Okay, like I said, the way you find the mean does not change. It's just still adding up all the values and dividing by the total number. So this is just the same. It's x1 plus x2 plus x3. And let's say this time you have capital N number of values in the population. So we add all the way up to xn, and then we divide by capital N. Once again, the book will also sometimes say it's the sum of the x's divided by the number of values. And this is where capital N is the total number of values in the population. Okay, so that is it for talking about x bar and mu. So I just want to clarify, they're both just means. Just x bar is when you're using a sample, and mu is when you're using all values in the population. So because of that, that makes x bar a statistic, and that makes mu a parameter. Any questions before we get into an example? Okay, so I have an example here that just tells us to find the mean of these numbers. So we have 12, 8, 14, 15, 11, 10, 5, and 14. So just using what we've talked about, all you're going to do is add them all up and then divide by the number of values that we have. So the mean here is going to be equal to just adding all of them up. So 12 plus 8 plus 14 plus 15 plus 11, 10 plus 5 plus 14. And then we just need to divide by the number of values there are. So does anyone want to tell me how many values I have here? So what should go in the denominator?
7.
Close, but it's 8. So really close, just off by 1. But this one is going to be 8. So I saw an 8 in the chat. So, okay, now we just have to add these all up. So definitely fine to pull out your calculator just to add these all up. Sometimes it's nicer to do that than in your head. So 12 plus 8 plus 14 plus 15 plus 11 plus 10 plus 5 plus 14. That should give you a total of 89. So this is equal to 89 over 8. And then remember when we first introduced this, we said that when giving the mean, it should always be one more decimal place than the raw data. So our data doesn't have any decimal places, they're just whole numbers. So that means that our mean should have one decimal place. So 89 divided by 8 is equal to 11.125. So our answer should just have one decimal place, so it's just equal to 11.1. I know it seems a little tedious and picky that we just want one more decimal place than the raw data, but it is important, so try and remember that when you're doing your calculations. I know your calculator will tell you that the answer is 11.125, but we just want 11.1 for this example. Okay, any questions on finding the mean? Okay, let's just briefly talk about some properties of the mean. So I won't get into them too much, but the first one says that the mean is a balance point of the data. So balance point may be a word that you haven't heard before, but I'm just gonna like talk about what it means. So the balance point would be the point on a number line where the data distribution is balanced. So let me say that in some other words. So let's say you have a number line and you have all of your data points on it. So let's say I make a number line of these data points that I'm given, and I mark them on the number line. And then I also mark where my mean is at on the number line. So the balance point, the mean being the balance point, means that the sum of the distances from the mean to all data points above the mean is equal to the sum of the distances of from the mean to all points below the mean. So I'm not going to go into that too much because I don't care too much that you know what a balance point is, but just think of it that where the mean is located, it means the distribution is balanced. I probably will not ask you what a balance point is on any like formal, like exam or quiz or anything. So don't worry too much about it, but I just wanted to talk about it and say that where the mean is located, the sum of distances from the mean to all the points above the mean would be equal to the sum of the distances from the mean to all points below the mean. So you can just think of it as being the point where it's balanced. And then lastly, when the data is skewed, the mean is pulled in the direction of the longer tail. So do you remember when we talked about distributions and we said something can be right skewed or left skewed? So if something is skewed, the mean tends to be pulled in the direction of the longer tail. So if something is right skewed, it means it has a tail on like the right side. So the mean would be pulled. Okay, those are just the properties of the mean. If you want, I believe they're also written in the textbook. You know what? These might not be. These ones might not be in the textbook. But you could definitely read more in the textbook about the mean, and they'll walk through some examples. If I'm finding it, just a little note, this is written in the syllabus. It does say that I'm not covering grouped data. So if you happen to read through the textbook and you see they're finding the means of group data and like the medians of group data and a bunch of stuff, don't worry about those examples because I'm not going to cover it. So just throwing that out there. It does say on the syllabus that I'm not talking about group data, but don't worry about it if you happen to read the text. Okay, so that is about all for the mean that we're going to talk about. Like I said, sometimes it's referred to as an average, so you may have heard it called that before. But now we're just going to get into our next measure of central tendency, and this is called the median. So the median is the midpoint of the data when they are ordered from smallest to largest. The middle number, and we use the symbol MD to denote the median. So if you have a data set and you go ahead and put it in order, the median would be that middle number. And luckily, we do have some steps to finding it. So number one is to arrange your data set in order. Number two says if the number of data points is odd, the median is just going to be the middle number. So if you have 7 data points, the median would just be the fourth number, because that's the middle, where there's 3 points on each side of it. But if your number of points is even, that kind of poses a problem because there really is no middle number. So when it's odd, there is a true middle number, and when the number of points is even, there isn't a middle number. So to solve that, we just take the mean of the middle two numbers. So I'm going to do an example, and I think that'll make more sense if you've never seen this done before. So down here, we have this example that says to find the median of the data set above. So our data set above was this one up here. So our first step is to arrange the data in order. So let's go ahead and do that really quick. So my smallest number is 5. So first I have 5. My next number is 8. And if it helps, sometimes when I do this, I like to cross them off as I go because that makes sure that I don't miss any numbers. So you can always do that. After 8, I have 10. And after 10, I have 11. And then 12. And then 14. And I have two 14s, and I need to list them both because I have two of them. So even though they're the same number, you need to list both of them. And then lastly, I have 15. So yes, 14 is the same number, but you will list it twice because it occurs twice in the data set. Okay, so this is a good example of when the number of points is even, because here we have 8 points. So there really is no middle point here. But to solve that problem, we just take the mean of the two middle numbers. So the two middle numbers here would be 11. The two middle numbers here would be 11 and 12 because there are 3 numbers on each side of them. So I know those two are in the middle. And to find the median, then what I do is just take the mean of these two numbers. So to find the mean of them, I just add them together. So 11 plus 12 and divide by 2. So this ends up being 23 divided by 2, which is equal to 11.5. So if there's an odd number of data points, your median's pretty simple and you just locate the middle one and you're done. If there's an even number, you have to locate the two middle points and then take their average or find the mean of them. Okay, any questions on how I did that with an even number of data points? Okay, my next example here is going to be with an odd number of data points. So I'm going to let you all try this one on your own right now. So go ahead and do this next example here and find the median of these data points. When you finish it, send me a private chat with your answer. So send me just a chat in Zoom, just to me, not to everyone, with the answer that you get. That way I can see how everyone's doing on it. And then when I feel like everyone's done, we'll talk about it for a second. I got 2 answers coming in. Just waiting on a few more answers. Just gonna give it another minute or so. Good. Okay, I'm gonna go ahead and stop now, but every answer that I received was correct. So if you sent me an answer, you got it right. But since I didn't get everyone's answers, I'm just going to go over it for a second. But good job, everyone. So first step is to order the data points. So let's go ahead and order these. Our lowest one is going to be 5. Next one will be 8, then 10, then 11, then 12, and then 14 and 15. Okay, well, this is not too bad since it's an odd number of points. We have 7 data points, so it's just going to be the middle one, which is going to be the fourth one listed, and that's going to be 11. So our answer is 11. Okay, any questions so far before I continue on to our next measure of central tendency? Okay, great. So our next one is going to be referred to as the mode. So the mode is the data value that occurs most often in a data set. So there's a few different vocab words that go along with the word mode. So because it's the data or the value that occurs most in a data set, you can have more than one mode. So maybe you're looking for the mode and you realize, oh, the number like 2 and 5 both occur 3 times. And that's the most that numbers occur. Okay, well, those would both be the mode. You can have more than one mode. You don't just have to have one. So then we get into some other terms called unimodal, bimodal, and then multimodal. So unimodal is when a data set only has one mode. So pretty basic. If you go to find the mode and there's only one, this data set would be called unimodal. If you go to find the mode and you find out your data set has two, it's referred to as bimodal. And if you have more than two modes, it's referred to as multimodal. So with that being said, you can have multiple modes, but I'm just going to write a note here that a data set doesn't even need to have a mode. So let's go ahead and do some of these examples together. I think I'm going to do the first two, and then I'm going to let you guys try the second two on your own. I want to make sure I cover everything in the lecture here. Okay, so my first example is this data set 12, 8, 14, 15, 11, 10, 5, and 14. Okay, so just by looking at it, I can see that the only one that occurs more than once is going to be the number 14. So my answer here for the mode is 14. And I'm just going to write this down. This is unimodal, since there's only one mode. Okay, so the next example is just 1, 2, 3, 4. And this one does not have a mode because each data point occurs once. So when you don't have a mode, it's important to note that you do write instead no mode, that you don't just write 0, because that's actually not correct. So if a data set does not have a mode, don't just put 0. That like gives the impression that the number 0 occurs the most in that data set, and it's really there isn't one. Good question. So why isn't it that they are all the mode instead of just no mode? Um, that's a good question. I don't like actually know why it was decided that if they all occur just once, that there is no mode instead of them all being the mode. Um, yeah, I don't know that there's like a good explanation for that in the textbook. Let me see if I can find something for you because that's a really good point. Yeah, no, good. None of them do repeat. But like, I guess you could say their frequency is all like one. So like, yeah, none of them repeat, but they all kind of have the same frequency. So, I mean, that's just a really good question to ask. Like, why? Because like they all occur once. Are they not all the mode? So it's just an interesting question. I'm curious if the textbook gives you an explanation why. Let me see if I can find one. Yeah, none of them repeat, but they all occur. They all technically occur most often if they occur once. Okay. Yeah, so the textbook just says when no data value occurs more than once, the data set is said to have no mode. So yeah, so I guess if nothing occurs more than once, it's just no mode. But that is a really good question. I don't know why the statistics world just decided that if everything occurs once, there's no mode versus they're all the mode. So, good question. I wish I had a better explanation for you. But I'm glad you brought up that point that if they all only occur once, then there is no mode. So, I'll write that down really quick so we all have that. So, when, okay, let me write a little note. So, when no data occur more than once, there is no mode. So, good question. Probably should include that in the lecture notes for next time. Okay. So let's talk about the next example. So our next example is 1, 2, 3, 4, 1, 2, 3, 4. So this is a good distinction between the last one where we had they all occur once. So there was no mode. But for this one, they all occur twice. So every single one is the mode. So for this one, our mode is going to be 1, 2, 3, 4. So the difference is that in the last example, they all occur only once, which the textbook defined as no mode. But in the second or the third example here, they all occur twice. So they all occur more than once, so they're all the mode. And then just to note, this would be multi. Okay, so why don't you guys go ahead and do the last example and then private chat me your answers when you finish it. So just tell me what the mode is on this last example. I'm gonna give you guys just another minute. Okay, so I got most everyone's answers. Most everyone said 1, 2, and 3, which is good. That is correct. So in the last example, you have 1, 2, 3, 4, 1, 2, 3. So the numbers 1, 2, 3 all occur twice, and 4 only occurs once. So nice job because the mode is 1, 2, 3. And this is again going to be multimodal. Okay, so now we're gonna get into this chart here. And this is just like a little exercise to make sure that you're understanding the difference between the mean, median, and mode. I think I'm just gonna do probably 1 and 2 and let you guys try the third one on your own. So this little chart here gives you some information. And basically you need to fill in the blanks based on what you're given. So in the first one here, we know that we have 5 data points, and we know the mean is 16, and we know that the mode is 8. So we want to come up with a list of data points that satisfies the fact that the mean is 16 and the mode is 8. So um, but first of all, we want to look at the information we're given and see what this really tells us about our list of data points. So when we have 5 data points, our mean is 16. So what does this mean? So if your mean is 16, it means that when I added up all 5 of the data points and then divided by 5, I got 16 as the answer. So in other words, your data points will need to add up to 5 times 16. So let me try and write that down and explain. So we know that when we add up all 5 of the data points, so let me write that over here. So when I add up all 5 of them, and then when I divide by 5, I know that I get 16 as the answer because my mean is 16. So when I add up the 5 data points and then divide by 5, I get an answer of 16. So using some algebra, this means that when I add up all the data points, and when I add them all up, that should give me 5 times 16. And 5 times 16 is 80. Okay, so just using what the properties of the mean are, that it's when you add all the data points up and divide by the number of them, I know that when I add up my 5 data points and divide by 5, I get 16 as the answer. Okay, so now I know that all my data points need to add up to 80. So I'm going to write that down really quick. So I know that my 5 data points need to add up to. Okay, and then I also know that the mode is 8. So this means that my data point that occurs most often is 8. So we don't know how many times 8 necessarily occurs, but we just know that it occurs more than the rest of the data points. So this is just kind of like an activity to see if you can come up with a data set or data points that meets these criteria. So just trying to really make sure that you know what the mean tells you, what the mode tells you, etc. So this is just an activity to make sure that you know your definitions here. I probably would not put anything too complicated like this on a test or a quiz situation, but just wanted to do it so that we could make sure we know our definitions. So let's just come up with 5 data points that satisfy these two things. So they add up to 80, and we know that 8 occurs the most often. So I'm going to make this easy on myself. If I want 8 to occur the most often, let's just go ahead and say that 2 of the data points are 8s. And then just make sure that the next 3 that we come up with are not. They don't occur more than twice, or they don't occur more than once, I should say. So right now, I have 8 occurring twice. So I just need to come up with 3 more data points that each occur once. And then when I add them all up, I get 80. So you can just, there are a lot of options for answers to this. You can just pick what you want. So I literally just picked, okay, let's see. So 8 plus 8 is 16. So 80 minus 16 means that I have 64 more that I have to account for. So my next 3 numbers in my list of data points should add up to 64. So I want all 5 of them to add up to 80. So I already have 16 accounted for because I have 2 8s. So I know that my next 3 data points need to add up to 64. So to make it easy, I literally am just going to pick 20, 40, and then 4. Just for fun. Just random choices. So let's make sure that those add up to be 80. So 8 plus 8 plus 20 plus 40 plus 4. Sure enough, that's 80. And if I divide that by 5, I get 16, which is what I wanted to be the mean. So good. The mean of this list of data points is 16, which is just what I wanted. The mode is also 8 because that's the number that occurs the most. 8 occurs twice, and every other number only occurs once. And then I just need to fill in what the median is. So anyone want to tell me what the median of this list of data points would be? Remember the, oh, there's some chat. Hold on. Good, 8. Awesome. So the median is 8. Okay, so that's it. It's just like an exercise just to see, okay, if I tell you how many data points I want and I tell you what like the mean or the median or the mode are, can you come up with stuff that satisfies it? That's it. So I won't do the other 2 since we have a lot more to get through in the next like 40 minutes. So maybe try it on your own. This is a really good exercise to see if you understand the definitions here. So try doing the next 2 rows and fill in with things that satisfy what you're given. Okay, let's see. Let's continue on, but are there any questions so far? Okay, great. So our next little definition that we're going to go over is called the mid-range. And this is the sum of the lowest and highest values in the data set divided by 2, and it is a rough estimate of the middle. So that's why it's called the mid-range. So to calculate it, you just add the lowest value and the highest value and then divide by 2. And it's just a rough estimate of where the middle is. But there is a little note here that an outlier, really large or really small, can have a dramatic effect on the mid-range value. And we're going to do an example here, and you'll see what I mean by an outlier having a big effect on the mid-range. So let's do this example. So this says just find the mid-range of the data. So we're just going to pick the highest value and the lowest value. So my lowest value here is 2, and my highest value is 13. So to find the mid-range, I just add these 2 together and divide by 2. And that is 15 divided by 2, which is 7.5. And that's roughly the middle of the data set. Okay, well, then it says, what if the largest value, 13, was incorrectly recorded as 31? What would happen to the mid-range? Well, let's go ahead and see what would happen. So if 13 was incorrectly recorded as 31, that means that my new mid-range would be 2 plus 31. Because now the highest value is 31 instead of 13, because it was incorrectly recorded. So if we add this together and divide by 2, now we get 33 over 2, which is equal to 16 and a half. You can see that this is a lot higher than the last one that we did. So 31 would definitely be an outlier if it was accidentally recorded instead of 13. And you can see that having an outlier of 31 in this set drastically affects the mid-range. So it goes from being 7.5 to being 16.5, which is doubled more than that. So just so you can know that a outlier can have a dramatic effect on the mid-range. So that's kind of the con. If there's some outliers, it can be a pretty drastic effect. That's really all we're going to talk about with mid-range. That's it. Any questions on the mid-range? Okay. So let's now talk about this thing called a weighted mean. So a new definition here, this is another type of mean. So the weighted mean of a variable x is found by multiplying each value by its corresponding weight and dividing the sum of the products by the sum of the weights. Okay. Um, so our example that we're going to do is calculating grade point average, which is a weighted mean. So you actually are probably a little more familiar with a weighted mean than you think you are. So calculating your grade point average is an example of that. So the reason why a weighted mean is a good option for this example, where we're given 4 courses and then the amount of credits that they're worth. So the English course is worth 3 credits, the calculus class is worth 4, and so on. And then we have the grades for each of those classes. So I'm trying to think of the best way to say this. So the calculus class is worth more of your GPA than the yoga class. It's worth more credits. So it has more weight when it comes to your GPA. So it doesn't really make sense to just do a normal average, because that would just mean that we add up the grades and divide by 4. But that doesn't really make much sense because they're not all weighted the same. So each class has a different weight in your GPA. So you can't just add up all your grades and then divide by 4, basically. We have to do what's called a weighted mean. And this means that we give the correct courses the right weights. So we calculate the mean by saying, okay, English is worth 3 credits, so let's take that into account. So your grade in English is not going to be worth the same as your grade in calculus because they're worth a different amount of credits. They have a different impact on your GPA. There's a way that we do this, and it's found by multiplying each value by its corresponding weight and then dividing the sum of the products by the sum of the weights. So let's just do that in this example here. So the first step is to multiply each value by its corresponding weight. So right here it says grade times weight. So let's just go ahead and do that. So the first one is English, and that's worth 3 credits. So I'm going to do the grade times the weight. So in English, you got a C, which is worth 2 points. So my grade is 2, and I'm multiplying it by a weight of 3. And that's equal to 6. And for calculus, my grade was an A, which is 4 points. So I'm going to do 4 times the weight is 4. So that's 16. Okay. So for yoga, I got an A, and that's worth 4 points, but the weight is only 2. So the credits it's worth is only 2. So we'll do 4 times 2, which is 8. Okay, my last grade was a B in physics, and that's 3 points. So that's 3 times 4 because it was worth 4 credits. That's 12. Okay, so I did the grade times the weights, and then it says I need to divide the sum of these products. So I need to add these all up, and I need to divide them by the sum of the weights. So I'm going to add them all up. So I have 6 plus 16 plus 8 plus 12. And then I need to divide them by the sum of the weights. So I'm just going to add these weights up. So I'm going to divide it by 3 plus 4 plus 2 plus 4. Okay, so my numerator is 6 plus 16 plus 8 plus 12, and that's a total of 42. My denominator is 3 plus 4 plus 2 plus 4, which is a denominator of 13. And then if I just use my calculator and do 42 divided by 13, I get about 3.23. But remember, when we're doing the means, we want one more decimal place than the data that we started with. So I just need one decimal place here. So this is roughly a 3.2 GPA. Like I said, you're probably more familiar with a weighted average than you think you are, or weighted mean. Sorry, it can be called a weighted mean or a weighted average. But you're probably more familiar with it than you think you are. And it just comes down to when you need to take a mean of things that are worth like a different amount of points, or they have a different impact on something. Okay, any questions on the weighted mean? Great. Okay. If you're looking for more on the weighted mean, I recommend looking at the textbook because I believe they go over more than one example. And the textbook has different examples than what I do in class as well. So if that's a little confusing, maybe just reading through the section in the textbook. All right, next page is properties and uses of central tendency. So now we're just talking about the four big things that we talked about. So we talked about means, medians, mode, and mid-range. We did talk about the weighted mean, but that's just another mean. And we're just going to talk about some of these properties and uses. So it does say read page 120. What follows are just the highlights. And that is very true. In the textbook, there's a lot more bullet points under each of these than what I'm giving you in the notes. These are just highlights. So definitely read page 120 because they give you more bullet points on each of them. So the first one is mean, and it says the mean is used in computing other statistics, such as variance and standard deviation. Those may be words that you've heard before, or maybe you're pretty familiar with them. But we are going to talk about those today, just in the next section. So you don't need to know what those are yet, but just know that the mean is used in computing other statistics. The mean is highly affected by outliers and may not be an appropriate statistic to use when an outlier is present. This is very true. So you'll see that sometimes the median is preferred over the mean when there's outliers present, because the mean is not a good representation when there's outliers. It's pretty easily affected, where the median's a little different. Okay. So the median, like it says, it's robust against outliers. It is less affected by them. So like we just said, sometimes the median is preferred over the mean because of that. And then the next thing is the median is used when one must find the center value of a data set. So anytime we were using the median up above, we were just finding that center value when we listed the data. The mode, so the mode is used when the most typical case is desired. So if you're looking at a data set that's talking about maybe occurrences of something, so if you're looking for the most typical case or the one that occurs most often, that would be the mode. Lastly, the mid-range. So the mid-range gives the midpoint of the data set. So we talked about the mid-range and how to find it, and it gives the midpoint. But then we also talked about how the mid-range is affected by outliers. So in that one example, we replaced 13 with 31, and we saw it was drastically affected. So the mean and the mid-range are both very affected by outliers, and the median is a little less affected. Okay, those are just some highlights though. So if you'd like some more uses and properties of these four things, definitely check out page 120. All right, this probably feels like a long section. I mean, it feels like a long section to me. So we are finally on the last part of section 3.1, and it is the location of mean, median, and mode on different distribution shapes. So we talked, I think maybe 2 days ago. I don't know, we've talked about a lot of stuff, but we talked about some different distribution shapes. And we said there's something called right skewed, left skewed, and then there's also that bell shape, or like it's symmetric. So we talked about, I think, more than that, but I'm going to talk about those three right now and just draw them out and show you how the mean, median, and mode are placed on these different distributions. So first, I'm going to draw a right skewed distribution. So my first one, I'm just going to label it A, and this is going to be a right skewed. Okay, so a right skewed, we remember the tail goes off to the right of the distribution. So it kind of like disperses out to the right. So I'm just going to draw a basic right skewed distribution. You can see the tail goes off to the right. I'm going to draw them all, and then I'll go in and label the mean, median, and mode. So next, I'll draw a left skewed. So left skewed just means that it goes out, the tail goes out to the left side. Okay, and then lastly, I'm just going to draw that bell-shaped one, or we also called it symmetric, but bell-shaped, and it's symmetric. If we remember back, it's called bell-shaped because if you outlined it, it has like a bell curve to it. So this is a symmetric distribution, so both sides of the center kind of look the same. Okay. So those are my three types of distributions that I'm going to talk about, and I'm just going to place where the mean and median and mode would be on these, just so you can get an idea of how having a right skewed or a left skewed or a symmetric distribution will affect the mean, median, and mode. So on a right skewed distribution, the mean is going to be about here. And at the very beginning, we did say, so let me scroll back up to the mean. So at the beginning, we said, when the data is skewed, the mean is pulled in the direction of the longer tail. So that makes sense because when the data is right skewed, it means that the mean is pulled a little bit more to the right. Our median here is going to be about this point. And then our mode here is going to be this one. You can see the mode is the one that occurs most frequently, so it's going to be the tallest one. And then the mean's pulled a little to the right, and the median is about in the middle of them. Okay, and for a left skewed one, it's going to be about the opposite of what we just drew. So now on the right side, this one's going to be the mode because it occurs the most often. It's the peak or the highest bar here. And then we're going to have the median next to it. And because it's a left skewed distribution, the mean is going to be pulled off to the left. And then lastly, the bell-shaped slash symmetric is really interesting because the mean, median, and mode all happen to fall in the center, all at the same place. You can see why maybe if we're working with distribution, something that's symmetric or bell-shaped would be preferred because the mean and the median and the mode are all the same and they're all in the center. So just some things to think about. I know you have some visuals and you can apply these measures of central tendency to those distributions that we talked about the other. That's going to wrap up section 3.1. So that's going to be it. I know that one was kind of long. It felt like there was a lot of content in there, but that's all I'm going to cover in the notes. So any questions before I move on to the last section for the day, which is 3.2? I definitely wanted to get through section 3.2. I'm not sure that we're going to completely get through it since there's only 20 minutes left. I don't want to rush it, but we'll see how this goes. I think it might go a little quicker, but if we don't get through it, that's okay. Okay, so section 3.2 is measures of variation. So lastly, we talked about measures of central tendency, and now we're going to talk about measures of variation, which is also referred to as spread. So variation can also be referred to as maybe the spread of the data. So like the notes say, to describe a distribution well, we need more than just the measures of center. We also need to know how the data is spread out or how it varies. So you don't just care about maybe where the center of the data is, but you also care about how spread out the data is from the center. So let's talk about why this is important. So to talk about why it's important, we're going to look at this example here. So our example gives bowling scores of Chris and Jared for 6 games. So the question says, who is the better bowler and how do you know? Okay, so if you're trying to figure out who's the better bowler, with what we just talked about, maybe finding the mean would be a good idea. So maybe finding the average. So maybe we want to know, okay, what's Chris's average score and what's Jared's average score? Whoever has the higher average score must be the better bowler, right? So that's a good idea. So let's see, we could use the mean. Okay, well, to go ahead and find the mean for Chris, I'm going to add up all his scores. So remember that the mean is adding all of them up and dividing by the number of scores. So I'm going to just do this on my calculator. So 185 plus 135 plus 200 plus 185 plus 250 plus 155. Okay, well, that is 1,110. So average, or actually, sorry, I should say the mean. I should be consistent here. So the mean is equal to 1110 divided by 6, because we're looking at 6 of his scores. And that is equal to 185. Okay, let's do Jared's now. So let's add up all of Jared's score. So 182 plus 185 plus 188, 185 plus 180 plus 190. Oh, interesting. So we get here 1110, so 1,110 again. Okay, well, divided by 6, that's also 185. Okay, now we're kind of stuck because we want to know who the better bowler was by finding what their averages were, what their means were. But both of them have the exact same mean of 185. Who is the better bowler? Are they both better? Is one better than the other? Um, I mean, I guess it's kind of up for debate, but just by looking at their scores, I would claim that Jared is the better player. And the reason I would claim that Jared is because his scores are a lot more consistent. So if you look at Jared's scores, his are in the 180s and the 190s, and they basically stay there. But if you look at Chris's scores, Chris's are all over the place. Yeah, he has a score of 250, but he also has a score of 135. That's pretty low. So he's kind of all over the place. I would say that Jared is better because he's more consistent and his scores are less spread out. So if you're going to bet on someone to win in the bowling game, I would say you bet on Jared more often because Chris is kind of a toss-up. He could either do really, really well or pretty poor, but Jared is going to be pretty consistent. So I would claim that Jared is better. So this is where we get into measures of variation, because Chris's scores are more spread out, so they have more variation, where Jared's scores are more consistent, and they're all around the same values. So I would say that Jared is better because his scores are more consistent and Chris's scores are spread out. So that's why we have to look at measures of variation as well, because our measure of central tendency was not enough in this case. Okay, so that's just an example to show you why it's important. So we have a few ways to measure spread that we're going to talk about. So we have three ways. We have what's called range, variance, and standard deviation. So range is not too bad. There's not too much of a calculation here. You've probably calculated the range of data before. So range is known as the difference between the largest and smallest observations. So to find range, you just do the high value minus the low value. So this says, what are Jared and Chris's ranges? Well, let's go ahead and calculate those. So let's do Jared and Chris. Okay, so I'm going to calculate Jared, and I'll let you guys do Chris's. So we want to find the highest value and then subtract the lowest value from it. So looking on Jared's side, the highest value is 190, and the lowest value is 180. So for Jared, we have 190 minus 180, which is a range of 10. Okay, so why don't you guys go ahead and do the range for Chris's scores, and then send me a chat when you have figured that out. Okay, I've got one answer, so I'm just waiting on a few more. Okay, good. I've got a few more answers in. Okay, so for the most part, they look pretty good. Let's go ahead and just do this one together really quick. Okay, so we want, let's see, Chris's highest score and Chris's low score. So go ahead and look at this chart. So his high score is super high, it's 250. And then his low score is 135. So to find the range, we just need to subtract 135 from 250. Okay, well, 250 minus 135 comes in at 115. All right, well, just by looking at that, you can see Chris's range is 115, which is pretty large. His scores vary by up to 115. And Jared's scores only vary by 10. So his highest variation between scores is 10 points. So that's a big difference here. So that is one of the ways to measure spread of data, is looking at the range. But we also have another method, which is known as standard deviation. And I would say this is probably one of the more popular ways to measure the spread. And we'll also talk about, within standard deviation, we'll talk about variance as well. So within standard deviation, we will hit the other two measures of spread, which variance and standard deviation are very closely related. So whenever you define them, you usually define them together. So I'll probably just end up doing this one example here of finding Chris's variance and standard deviation. And then we'll see. There's not like another example to do, but I'll probably have to wait on the empirical rule and talk about that at the beginning of class tomorrow. I will probably be waiting on the empirical rule until tomorrow. So we'll just talk about standard deviation right now. Okay. So sample standard deviation is denoted by a capital S, and it is a measure of how far the data values are spread around the mean of a data set. So it's just another measure of spread, so how far they are around the mean. We have some steps written down here for how to calculate it, which is really helpful because we're going to go through an example and do steps 1 through 5 together. But after that, there's also a formula for population standard deviation. So remember at the beginning, we talked about the difference between using the whole population and using just a sample, and how when you use just a sample, it's called a statistic, and when you use a population, it's called a parameter. So here, there are two different formulas for standard deviation. They are barely different, but one is for a sample and one is for a population. So I'm just going to quickly point out the difference here. So for sample standard deviation, the denominator has n minus 1. And in population, the denominator is just n. So that's really the difference here. The other thing is that in the formula, the mean is referred to as x bar. And that's because, remember, at the very beginning of class, we said the mean of a sample is x bar, and the mean of a population is mu. They are both means, but one is of a sample, one's of a population. So really the formulas almost look identical, minus the denominator here being n minus 1 and the denominator here being n. Just to give a brief explanation, the one for sample standard deviation is n minus 1, just because sometimes when a population is large, but the sample you're using is small, it tends to be an underestimate. So they change the denominator to be n minus 1 instead of n, just to kind of make up for that underestimate. So, I mean, I'm not going to require that you understand why it's n minus 1 versus n, but I just wanted to throw that out there in case anyone's wondering why it's different. So once again, it's just because sometimes when your population is large and your sample that you're using is small, this is actually like an underestimate if we just divided by n. So they just change it to be dividing by n minus 1 instead. So just to kind of explain that. So there are 5 steps here for calculating standard deviation. I think we can get through the 5 steps and that'll probably be it for today. So let's go ahead and do this example here. That is, use Chris's data to find his variance and standard deviation. Okay, so this is the formula for standard deviation here. But these steps really walk you through kind of what the formula like means. So I'm going to really focus on the 5 steps. So step 1 says to calculate the mean, which is x bar. So in this case, we are using a sample of Chris's scores, and we're going to just calculate the mean. So step 1. Step 1. So calculating the mean of Chris's scores. I'm going to come back up here though. We actually already calculated the mean at the very beginning when we were comparing them. And the mean of Chris's scores was 185. So I'm just going to write that down. So in our case, x bar, or the mean, is equal to 185. Okay, so we already had the mean calculated, so that wasn't too bad. Step 2 is going to be calculate the deviation from the mean for every data value. Okay, the word deviation means how far away it is from the mean. So for every data value, I'm going to take and subtract the mean from it just to see how far away it is from the mean. So step 2, I'm going to take every value and subtract the mean from it. So let me come up here to Chris's chart. So I'm going to take each one of these scores separately and subtract the mean. So first I'm going to start with 185 because that's his first score. So I have 185, and then I'm going to subtract the mean from it, but in our case, the mean is also 185. So that's just 0. Okay, well, his next score on the chart is 135. So I'm going to subtract the mean from this one. So 135 minus 185. That's going to be a negative number, but that's okay. That's going to be negative 50. Next, his score is 200. So I'm going to subtract the mean from 200. And this is just 15. His next score was also 185, and to subtract the mean from that is again just 0. I'm actually going to just highlight these answers because they will be important. Okay. His next score was 250, and I'm also going to subtract the mean from this. So 250 minus 185, that's equal to 65. And lastly, his score was 155, and I'm going to subtract 185 from that, and that's going to give us negative 30. Oh no. My PDF app crashed. Okay, my work is still there. Let me just, I know. My laptop this is the first time I've taught, like I said, and my laptop is apparently not used to an hour and 45 minutes of me using a PDF. Okay. So lastly, I was doing 155 minus 185, and that's going to give us negative 30. Okay, and that's all that step 2 asks you to do. So step 2 just says calculate the deviation from the mean for every data value. So for every data point, I subtracted the mean from it. Okay, step 3. Step 3 says to square all the values from number 2 and sum them up. So every highlighted value here, I'm going to square and add together. So 0 squared is just 0. Negative 50 squared is going to be 2,500. 15 squared is going to be 225. I have another 0 squared. 65 squared is going to be 4,225. And lastly, 30 squared or negative 30 squared is going to be 900. Okay, now I just need to add these together. So I have 0 plus 2,500 plus 225, 0 plus 4,225 plus 900. Okay, and that's equal to 7,850. Okay, and we're almost done. So step 4 says to divide this number by the total number of data values minus 1. And that's because in our formula we have divided by n minus 1. So step 4 is to take and do 7,850, and we're dividing by 6 minus 1. Because we had 6 data values, but our formula says to divide it by 6 minus 1. So this is 7,850 divided by 5, which is 1,570. And our notes tell you this number is actually called the variance. So our variance is 1,570. This is one of our answers for this question. Lastly, step 5 is how to find the standard deviation, which is very easy. The standard deviation is just the square root of the variance. So the standard, or sorry, I'll just refer to it as x. So f is equal to the square root of 1,570. Just using my calculator, that is about 39.6. Okay, so those are the steps. So step 1, you find the mean. Step 2, you subtract the mean from every data point. Will you be able to use formulas for standard deviation on quizzes/exams? A good question. For now, I'm gonna say no, mainly because I will give you small data sets. I know that this takes a while to compute. So for right now, while we're learning how to do it by hand, I'm gonna say no, because I want you to know how to do it by hand and use the formula. But I will always give you a small data set if I'm asking you to do it by hand. Like it would be no more than 6 points, because 6 points alone took a little bit of time. So if I'm ever asking you to do it by hand without using like an Excel sheet or something, it will be a small set. So for now, while you're learning it, I will say no. But possibly in the future, when we're doing like large data sets, that's totally fine with me. I just want you to understand how it's computed first. Good question though. Oh yeah, big data sets are so ugly with standard deviation. And it's like you make one little mistake. So like you subtract the mean wrong once and your whole answer is blown. Like it's just wrong. So no, I won't make you do a big data set by hand. Okay, I am over time by 1 minute, so I will go ahead and stop the recording really quick.